Hello everyone. This is about the breakthrough that changed how machines understand language. For decades, models process text sequentially, struggling to remember long range context, forgetting what appeared earlier in a sentence, collapsing under complexity. Then came a radically simple but powerful idea. Instead of processing words one by one, let every word look at every other word all at once. That idea reshaped natural language processing. It powered models that can translate, summarize, answer questions, write code, and even hold conversations like this one. Today, we are stepping inside that mechanism. We will uncover how attention works, why one attention layer isn't enough, how multi head collaborate, how transformer blocks stack, and how all of it turns into generated text. By the end, you won't just know what a transformer is, but you will understand how it works. Let's begin. One attention is not enough. We have already seen in our last video how self-attention works. Each word in the sentence looks at every other word. It assigns importance. It builds context. That's powerful. But now let's pause and think about language itself. Language is messy. It's layered. It carries grammar, meaning, emotion, intent, long range connections, cause and effect relationships, and references that stretch across entire paragraphs. When you read a sentence, you're not tracking just one type of relationship. Instead, you're unconsciously tracking many. So here's the real question. Can a single attention mechanism, one mathematical perspective, truly capture all those different relationships at the same time? Probably not. And that realization led to something brilliant. The breakthrough idea, how different heads sees different things. Researchers asked a simple but profound question. What if instead of giving the model one attention mechanism, we give it many? Not one perspective, but multiple perspectives. Imagine several analysts reading the same sentence at the same time. One specializes in grammar, another focuses on meaning, another tracks references, and another looks for cause and effect. Each analyst produces their own interpretation of relationships. Then their insights are combined. That idea became multi-head attention. What multi-head really means? What happens internally? A head in multi-head attention is simply an independent attention mechanism. Each head has its own set of learned parameters. Each head calculates its own attention scores. Each head captures different patterns in the sentence. They all look at the same words, but they don't look for the same things. One head might strongly connect it to animal. Another might focus on the causal relationship created by because. Another might emphasize the overall sentence structure. Instead of forcing one mechanism to understand everything, we allow specialization, and that dramatically increases expressive power. When you look at this diagram, it might seem complicated at first, but let's decode it step by step. And more importantly, let's compare it to the single attention so it really clicks. In single attention, you take the input embeddings and create three things: query, key, and value. Your compute attention once, you get one set of attention scores, you produce one contextual output, one perspective, one interpretation of the sentence. Now look at this image. At the bottom, you still see query, key, and value. That part hasn't changed, but notice something important: they go through multiple linear layers. Why? Because instead of creating one version of Q, K, and V, we create multiple versions. Each linear layer is essentially preparing a different projection of the same sentence. It's like giving the same input to different analysts, each with their own lens. Then in the middle, you see multiple scale dot product attention stacked side by side. That's the key difference. Instead of computing attention once, we compute it multiple times in parallel. Each block is a separate attention head. Each head calculates its own attention scores. Each head learns to focus on different patterns. Each head produces its own contextual representation. So, while a single attention mechanism says, "This is how I think the words relate," multi head attention says, "Let's examine this from several learned perspectives at the same time." Now, look at the top. After each head produces its output, we don't just pick one, we concatenate them. That's the concat block. We stack all those different perspectives together. Then we pass them through one more linear layer. Why? Because now we want to combine those multiple viewpoints into one richer, unified representation. So compared to single attention, 1Q, 1K, and 1V, one attention computation, and one relational view. Multi-head attention, multiple Q, K, V projections, multi-attention computations in parallel, multi-relational views, then merged together. This is what gives transformers depth in understanding. One head might specialize in grammar, another might focus on long range dependencies, another might track references like it pointing back to a noun. They are not manually assigned these roles, they learn them during training. And that's the beauty of this architecture. It doesn't force one mechanism to understand everything, it allows specialization, parallelism, and then intelligent combination. That's why multi head attention is not just more attention, it's structured diversity inside the model's reasoning process. Why this changes everything? When all these heads finish computing their perspectives, their outputs are combined and transformed into a richer representation. Now, the model is not relying on a single interpretation, it's blending multiple relational views of the same sentence. That's why transformers can handle ambiguity. That's why they manage long range dependencies so well. That's why they scale. Multi head attention is not just a tweak, it's the reason transformers became dominant. And it is one of the core ideas that powers every modern LLM you use today. Up until now, we have been talking about attention like it's a powerful component, but this slide is where you realize something important. Attention is not the whole transformer, it's just one part of a repeating engine. Inside a single transformer block, the story unfolds in a very deliberate rhythm. First comes multi head attention. This is where the model looks across the entire sentence, compares tokens, weighs relationships, and builds contextual understanding. Each word updates itself by listening to every other word through multiple specialized heads. But we don't immediately move on. After attention reshapes the representation, we pass it through something called add and normalize. The add part is a residual connection. It keeps a copy of the original input and adds it back in, preventing important information from vanishing. The normalized part stabilizes the values so training doesn't spiral out of control. Think of it as recalibrating the signal before moving forward. Then comes the feed forward network. This part doesn't look at other words, instead, it processes each token independently through a small neural network. If attention is about communication between words, the feed forward network is about deeper thinking within each word's representation. It transforms, sharpens, and refines what attention discovered. And once again, add and normalize another residual path, another stabilization step. The model preserves what matters while carefully adjusting what changes. Now, here's the part that changes everything. The entire block, attention, add, normalize, and feed forward, add and normalize, doesn't run once. It repeats again and again and again. Each layer builds on the previous one. Early layers may capture surface level patterns like grammar. Middle layers start recognizing relationships and structure. Deeper layers begin forming abstract semantic understanding. This stacking is how models like GPT scale, not by making one giant attention mechanism, but layering many transformer blocks on top of each other, gradually refining the representation at every level. And that naturally raises a bigger question. If layers keep refining representations, how does this turn into actual words being generated one by one? How does a stack of mathematical transformations become a sentence on your screen? That's where we move next, from understanding structure to understanding generation. And that's when the transformer truly comes alive. Thanks for watching. If this video helped you, hit like, share it with friends, and subscribe to Decode Bro for more insightful content. Stay tuned for the next episode. Until then, take care.